we know for zero order reaction, X is equal to Kt, where X is the amount reacted, K is the rate constant, T is the time. So since X is the amount reacted, we can write X is equal to A naught minus A, initial concentration minus concentration at time T, and this on rearranging it becomes like this. So here you see this equation is of the form y equal to mx plus c. So to know whether a reaction is zero order reaction or not, okay, we can plot concentration of A versus time, okay, concentration of A versus time, and if the reaction, if the given reaction, if the reaction that is under study, it will be zero order, if we get like this sort of experimental points, if we get like this sort of graph, then we can say that it is a zero order reaction. If on plotting concentration of A versus time we are not getting a straight line, then we can say that it is not a zero order reaction. So just see, this is first order, this is zero order. In case of first order, plot of log A versus time is a straight line, whereas in case of zero order it is concentration of A versus time, it is a straight line. Suppose you are asked a question in exam, it can be asked, say, what is the graph of log A naught by A, what is the plot of log A naught by A versus time for first order reaction. For first order reaction, what will be the plot of log A naught by log A versus time? Now you see, we already know for first order reaction, this is the thing that we get. So you see, it is of the form of y equal to mx. This entire thing, if you consider thing as y, this as m. So and since graph of y equal to mx is a straight line, so this plot also will be a straight line passing to the origin. So this will be the graph in that case. Okay. So this is about how we can understand whether a given reaction is a zero order or first order. Okay, children, next we have a reaction which is called pseudo first order reaction. What is pseudo first order reaction? Pseudo first order reaction. Suppose we consider this reaction, say hydrolysis of ester. Hydrolysis of ester. Let me write down a equation. CH3, C double bond O, say C2H5. It is an ester. Ester reacts with water in presence of acid as catalyst, and it forms CH3COH plus alcohol. This reaction is called hydrolysis of ester. Now, this reaction has been studied, and the rate law expression has been found to be that it is a second order reaction. This reaction is a second order reaction, and rate law is found to be like this. It is concentration of ester and concentration of water. So there are two concentration terms here, and that's why it is a second order reaction. But under a certain condition, we can make this reaction behave as first order. Under a certain condition, suppose water, which is one of the reactants, suppose water is in large excess. Suppose water is in large excess, then we can take this concentration of water to be constant. It will become constant because since water we have taken in large excess, then there won't be any change in the amount of water. There won't be any decrease in the amount of water. So concentration of water will be same, will be constant. So this equation then becomes R equal to K ester. Let the concentration of water which is constant is K prime. So K into K prime will become K double prime. Say ester. So you see now the rate law becomes like this, and there is only one concentration term, so it will behave like a first order reaction. Such a reaction, which is normally second order, but behaves like first order under certain condition, they are called pseudo first order reaction. Now, in the same way, if we have ester in large excess, then also it will behave like first order reaction. Okay, children, next we have here a typical gaseous reaction. Suppose A gaseous forming B and C as product, both are gaseous, and so it's happening inside a container. Suppose the initial pressure of the system, that is at time t equal to 0, is Pi. So Pi is our initial pressure, and and suppose PT is the total pressure of the system at time t. So Pi is the initial pressure, PT is the total pressure, and so at time t, we can write that some amount of A will decrease. That's why Pi minus X, and if some amount of A decreases, same amount of B and C will be produced. So that's why if X is a decrease in pressure for A, there will be X pressure formed of B, X pressure formed of C. So this is the pressure of the reactants and products at time t, and total pressure, according to Dalton's law of partial pressure, total pressure will be sum of these three. So Pi minus X plus X plus X. This one simplifying becomes Pi plus X, and from here we can write X amount reacted will be Pt minus Pi. Okay. Now, if this is a first order reaction, we can write this expression log A naught by A, where A naught is the initial concentration, this is the concentration at time t. Okay. Now, since Pi is the initial pressure, then AO will be directly proportional to Pi. So for AO we have written Pi, and likewise concentration at time t will be proportional to the pressure at time t, and pressure at time t will be Pi minus x, the pressure at time t. And next what we have done here, we have substituted the value of x, here, and on simplifying we get this one. So 2.303 by T log Pi divided by 2 Pi minus Pt. So we are getting the rate constant in terms of initial pressure and the pressure at time t. So this you need to know, there will be maybe some numericals on this.